Question.
Thank you.
There's one more section we didn't have covered yet for chapter 6. So we'll do that the first half of class, and then the second half you can work on more Alex, and I can help you with the questions that you have. Especially using the table, using the calculator back and forth, to make sure you understand.
Oh, well, Project One, I attempted it. But when they showed up the line in the graph, it didn't look right. I just took the photographs from because that is had the trend line.
That's fine. Was there any questions on anything so far? So the central limit theorem, it's a sampling distribution, all right, let's get by. A sampling distribution of sample means, a distribution obtained by using the means computed from random samples from your population. A lot of words. What it means is if I wanted to do, say my population was all students in stats class at YSU. Of course, I can't do all of them, depending on what data you're trying to find. But I could take half of the classrooms. So each one of those would be a sample from the population. You find the average of each one individually, and then you average them together. And that's what they mean by a sampling of means. You're taking different samples. Now, that changes it a little bit. The sampling error is how much you could be off, because maybe it's not a good sample from your population. If you're in an honors class, then that, if you chose that class is definitely, well, should be higher than your average. So then the, whatever you're trying to measure, it's biased. And so there's a sampling error. The sampling error is your standard deviation divided by the square root of the population. Or the sample, not the population. Oh, it's not, I saw population.
That's not very.
The symbols they use. So this is the mean of sample. And the mean of sample means is equal to the population mean. But the error is not the same. That's what this is telling you. The sample error is this right here. So when you're taking the standard deviation of samples, the standard deviation from the population divided by the size of the square root of the size of the sample. That's your sampling error. So the error for the sample of means is smaller than the error for the population, because notice we're taking the error for the population and dividing by the sample size square rooted. And that's what it means by it's smaller. So what you have to be careful of, they give you the mean, the standard deviation, and then they say we're taking sampling of 36 people, then it's going to be the sampling mean and standard deviation, not one individual. So the problems we had before, well, no, not that. Assume the scores are normally distributed. Find the lowest possible score. They're not having given a sample of so many, find the lowest possible score. It's an individual. The next group will be samples. What the central limit theorem says is, as the sample size n increases without limit, the shape of the distribution of the sample mean taken with replacement from a population mean and standard deviation will approach a normal distribution. So as long as your sample size is long enough, you can assume it's going to be a normal distribution. If it's not large enough, then it needs to say that the variable is normally distributed. Well, what's large enough? Greater than 30. So they say if your data is larger than 30, it will eventually make a normal distribution. When it's not larger than 30, then you need to have it state that the variable is normally distributed. If it doesn't, then at least you can't solve it that way. So all of ours should, or maybe they'll say can't be solved with normal distribution on Alex. So if your sample size when you're getting these samples is not greater than 30, then somewhere in there it needs to say the variable is normally distributed. Any questions so far? So when we're finding our Z, well, I think I have the formula. It'll be a little bit different for the Z value. When using the central limit theorem, the original variable is normally distributed, then the distribution of the sample means will be normally distributed for any size. So that's saying what I just said. As long as if it says that the variable is normally distributed, then the sample can be any size. You don't have to worry about it. But if it doesn't state that, then it has to be greater than 30. So all I do is I look at the sample size first. If it's less than 30, then I look for that. If it's greater than 30, it doesn't matter. The value that we use for the Z-score, this is the formula then. The X is still, you'll be given an average. But it's here minus the population mean. And then this part, I usually calculate ahead of time. The standard deviation divided by the square root of n. Easier to plug in. Alex says if you're doing any estimates like that beforehand, round at least 4 decimal places. So if it's not your final answer, when you plug it in here, go 4 decimal places. Or plug it all in at once. If you entered it all at once, unless you have a fraction bar, this has to be in parentheses. So let's try. Well, these are solved just like before, except for the formula for the Z values, just a little bit different, but everything else is the same. The average drive to work is 9.6 miles. A standard deviation of 1.8. If a random sample of 36 employed people who drive to work are selected, find the probability that the mean sample is between 9 and 10. So our sample size is 36. So we're finding the probability that's between 9 and 10 miles. Is the assumption that the distribution is normal needed? Did it need to say the variable was normal? All you do is look at the sample size, it's 36, it's greater than 30, so it's not needed. So it's not needed because (36) is greater than 30. So as long as the sample size is larger than 30, you don't need it. That's the first thing you have to do. I kind of put these in the steps that you'd want to follow. So when you're doing them on Alex, you'll follow the steps. The next thing, I like to find the Z values before shading because the Z values tell you if it's above or below 0. Sometimes looking at them, you can't always tell, but you should be able to. This is the mean, it should be in the middle. So this would be below and this should be above. This should be negative and this should be positive. Just looking at the mean, you can see that. Now to find the Z value, I would find this first, which population mean and the sample of means is the same. Standard deviation is 1.8 divided by the square root of n. It's your standard deviation from the population divided by, I'm going to put it in there, the sample size, which is 36. Which should be 0.3. Any questions so far? This one's nice because it's a terminating decimal. And we need to find the Z value for 9 and 10. So this is the only part that's different. Now, if you wanted, instead of doing it this way, we could have done a 9 minus 9.6, 1.8 divided by the square root of 36.
This is when it's not.
If you're doing a sampling size, you always have to do this.
Yeah, but I mean, like, you don't have to give them to the same student.
Yeah, whether you find that value here or plug it in here and just get the final result, that's up to you. I find students make less mistakes if I write this way instead of this way. But these should give you the exact same answer. Does that answer your question? So the reason we're using this is because we're taking samples from the population of size 36 rather than just one. Before we were doing just one, if we put the square root of 1, it's not going to change anything. So then they just didn't use that. Maybe they should always use it. So 0's in the middle, -2, so it's 2 standard deviations below. Above is the other one, 1.3. And we want the area. -2. So -2 is here. Remember, the table gives you the percent below. So that value would be here. An area that we don't want. Now, when we look at the 1.3, that's going to give us all of this. Notice it's giving us everything below. So if we take this one out, it will give us what's in between. So whenever you're looking for in between, you subtract the two. 1.3. $1.3. And then this first column is the second decimal place, which would be 0. So it's so if we take the larger part and subtract this small triangle, so the probabilities between 9 and 10 is 0.8854, 88.54%. Any questions? Go ahead and do the second one. The average number of moves a person makes in his or her lifetime is 12. I think that's kind of high. If the standard deviation is 3.2, find the probability that the mean of a sample of 36 people is less than 10, greater than 10, between 11 and 12. Well, first, is the assumption of normal necessary? No, because sample size is large. So for part B, you could follow these steps, B, C, D. Find your Z value, shape your curve, and then find the area. For each problem, that's the 3 things you'll want to do. I wrote the steps up here, that way I could switch to the table. Although, are you noticing about your value? Did anyone get the first one, the Z value? It's pretty large, isn't it? I think it was negative 3.7. If you put the decimal here, it was. So if you are taking the decimal here to plug into your formula, go 4 decimal places or you won't match Alex. See. You're getting a negative 3.75.
Wait, why'd you go 4 decimal places?
Anytime you're rounding in between something, you should go 4 decimal places. 32 out. Since we're using this in another formula, go at least 4. Or keep the whole thing. Now, if you use the table, notice that it only goes to negative 3.4 9 because it rounds to 0 after. But I looked this up because I took this one from the book thinking I'd get better numbers, although this one's not the best number. So I would accept 0. Well, I guess we didn't put the amount first. Let's put the where the 0 goes. So we were looking for less than 10. So it'd be here. Using the table, it would be 0. That would be the percent here. If you use the calculator, that's not following up with this one. So we want we want less than negative 3.75. See, it's so small. 2, 4 zeros. So on the table, I won't let this happen on a test, the number will be there. But if you were using the table, it'd be 0. If you're using the calculator, Alex would want you to go to, if you can't go 2 decimal places, they want you to go to the first one you can get. So this would be a 9. But it's so small, 0. Any questions on that? So using the table, it would be a 0. And Alex might accept either answer. I'm not sure. I didn't find one where that happened. I did try all of them. Any questions on that? For part C, it's asking for greater than 10. Well, the Z value is the same. Only this time we want greater. If we type this in, we're still going to get the value for less than. So what do we have to do to find out greater than? What should we do? We know this is, we know the whole thing is 1, so we subtract that from 1. Now, if you were using the 0, then your answer would be 1. You're using this one. Because remember, it's its complement. They need to add up to 1. So if less than is, well, we rounded it to this. If less than is this, greater than has to be 1 minus that. Any questions on that? So if you use the 0, then it would be. Because remember, a probability can be anything between 0 and 1 inclusive. Any questions on that? Okay, go ahead and find between 11 and. First, find the z-scores, and you'll find two of them. Then graph the normal distribution. Now, these ones we'll find on the table. Getting a negative 1.88 for the 11. What are we getting for the 12? 0. So you got negative 1.88 and 0. And 1 in between. So what should we do once we find the two proportions? Mhm. And what do we know the 0 one is? What would be the percent below 0? It's a half. It splits it in half. You don't even need to look that one up. But if we did 0.5. So 0.5 is all of this. So we need to subtract this corner out. When we look this one up, that's the percent below. Was the negative 1.88. So here's the 8, then it goes, well, if you go to the end, it's a 9, 9, 8. So it's this. Four, 6, 9, 9. That's if you write it as. So the proportion would be written like this. If they want it written as a percent, 46.99%. Any questions on that? Did I subtract them? I was doing them right before class, so I definitely took them. Although I think I was checking them, this one was in the book. Any questions on?
Why did you use the 0.0301?
It was a negative 1.88. So I went down to where 1.8 was here, and then I went across to the eighth one. So it starts with 0, 1, 2, 3, 4, 5, 6, 7, 8.
So you just deliver how many decimal points?
The second decimal place, yes. This helps a little. So this would be negative 3.40, negative 3.41. So this is giving you the second decimal place.
Okay.
It's, you're welcome. It's just once you won't go down too far, it doesn't show there. Any questions on that one? Number 3. Do we need the assumption that it's a normal distribution?
Yeah.
Yeah, so this one, we would need the assumption that it's a normal distribution because the sample size 15 is less than 30. So since this is less than 30, it should have the assumption that it's normal, but I don't know that I typed it in there, but it should have. Mhm. Okay. Because we're taking samples rather than one individual.
So they'll tell us.
It'll say a sampling of means or sampling. Selected samples of 15 people. Sample of 36 people. So when it doesn't have that sampling size, then you just use the standard deviation from the population. What you're doing is for this one, you divide it by the square root of 1 because there was 1. So they didn't put that in there. If it doesn't have normally distributed, you couldn't use Z no matter what. There's a T distribution, which we'll learn in later chapter. I think we should. So when it's not normally distributed and your sample size is small, there's what's called a T distribution. But we haven't learned that. Getting the same values for your Z, only one's negative, one's positive. Because it's an equal number of units. 123 is 3 units either way. So your Z value should be the same, just one positive, one negative.
I never know which one.
Oh, 4 decimal, well, okay, I understand. Z values are always 2 decimal places. The table only goes to 2 decimal places.
So
So Z values are always 2. That wasn't the Z value. This was the Z value. This was the standard deviation. If you're not going to use this whole thing for your next computation, then you have to go 4 decimal places. So if it's something you're going to use again, you need 4 decimal places. But once you're finished, if you're finding the Z value, you go 2. Z value is always 2. Maybe I'll get a sheet. Round. So technically, you should never round till the very end. But Alex is allowing you, as long as you go 4 decimal places, so you don't have to carry everything. Sure, that was a knock for someone then. Oh, the table. Negative 0.55. 0, 1, 2, 3, 4, 5. So this would be 0.55. The negative one. That gives us this. Because when we look below, the table always gives us below. Another way you can check that. It will show you. It's always giving below. So when we look up 0.55, it's gonna give us this. But we only want in between, so if we take this one and subtract this, we'll be left with that middle part. 0.55. So 0.5, to get the next decimal place, 0, 1, 2, 3, 4, 5, right here. So this is the whole thing. If we subtract this out, we have the part between. Any questions on it?
So to find a book, we subtract it from one. Subtract it.
So to find above, you subtract from 1.
Yeah.
When they're in between, you subtract them. If you're looking for below, it's gonna give you below.
Yeah.
So if we wanted below negative 0.55, that's that value. So it gives you below.
Table indication.
So if you're looking for below, the table gives you it.
So what's the thing?
Oh, because of the zero.
Between.
If you look up 0, it's 0.5. So below 0 is 0.5. And we want it in between 0 and the negative 1. That's why we subtract it. So if you have two values, you're going to have to subtract them. So if you have two values, you subtract them. If you're looking for below, that gives you the answer. If you're looking for above, you have to subtract from 1. So this problem here, number 2, had one of each. So. And somewhere, I had put all the steps, but I think it's easier to just graph it and think about it rather than trying to remember things. Oops, there's one more. Here it is. Not coming up very good. But. To the left, when you look it up in the table, that's the area you use. To the right, subtract from 1. In between, then you subtract them. So this procedure table, which is in the outline that I have online, will help you. Number 4 is a little different. The standard deviation of a variable is 15. If a sample of 100 individuals is selected, compute the standard error. Standard error is your standard deviation. And this would be for a sampling because we're taking a sample of 100. Now we're assuming it's normal. Oh, its sample size is large. It doesn't have to be, right? So you want to find. Does anyone want to say what they're getting?
Mhm.
1.5? It would take 15 divided by the square root of 100. Square root of 100 is 10, and the 15 is 1.5. So the standard deviation is a sampling of means for sample size of 100 is 1.5. That's your standard error, how much they will vary. When you're taking samples, they vary less. What sample size is needed to double the standard error of the means? So if we wanted to double this, how could we find a sample size that was needed? So when you're doing studies, a lot of time you're looking for the sample size. How much do I need so that I'm going to get good answers? If I want this to be double, 1.5 doubled is what? 3? So I want to know what sample size I need so that this will be a 3, because that would be this double. So if you want it doubled, you multiply by 2 and you get 3. So then you just solve this for n. What should I do first?
Multiply by the square root of the size.
Multiply by what?
The square root of the size.
You can multiply by the square root of n, or you can place this over 1 and cross multiply. Either way. But you need to get the square root of n on the other side. Because you want to get it out of the denominator. Then what? Divide by the 3? Then what? How do you get rid of a square root? Square. A square root is a fractional exponent. It's 1/2. If we square that, 1/2 times 2 is n. So to get rid of a square root, you square both sides. So if we have a sample size of 25, we will have a sample standard deviation of 3. Any questions on that? So whenever you have a square root, to get rid of it, you square both sides. We'll use that a lot. That was B. What is the sample size needed to cut the standard error of the mean in half? So you want to cut that in half. Divide by what? 2. You multiply by half or divide by 2? I don't know. What do we get? 27. So as your standard deviation is getting smaller here, our sample size is getting smaller.
I think T is pretty good.
Oh, wait, 15 by. I would have thought doubling, but I did make a mistake though. I would have thought doubling this would have needed to be larger, but it doesn't. Wait, did I divide 15 point? It's 20. I knew something was wrong. Did you get a 20 here, not a 2?
Yes.
I knew I did something wrong. I don't think I had the decimal place right.
I think it's totally.
Oh, that's where. I
Yeah.
made the mistake.
So we did something.
Okay, that's why. This is this. I knew I did something wrong. So to make this smaller, less error, your sample size should be getting larger. So on this one, we're getting an error of 0.75. Our sample size is large. Notice on this one, 3, when we doubled it, we only needed 25. That's how much error you have. At 100, it gave us an error of 1.5. So the larger your sample, the smaller the standard deviation, because there's going to be less error. You'll be closer to the real proportions. Or the true mean. And that's what the central limit tells you. The larger you get, the more accurate it will be. Any questions on that? You would definitely get something like this, but I mean, I wouldn't have all these parts on the test. But you'll have one where you have to find a sample size. Any questions?
Wait, can you explain T again?
If we look at, what did we get here? 25 for 3. So if we look at one, I should have probably put this one at the bottom, but as the sample size gets larger, the standard deviation gets smaller. This one is the smallest sample, the standard deviation is larger, it's less accurate. So the larger your sample size, the smaller the standard error. But you can't always get a sample that large, so then you've got some error. Any questions on that? So I think it's a good problem to help understand that this is the amount of error. And the bigger your sample, the better or the smaller the error. Any questions on that? Any questions on what we covered today? So if it says a sample size or sample means, you need to use these formulas. Was there any problems on Alex that you want me to do up here, or do you want to just work on them individually and I'll come around and help you?
Individual.
Okay. I'll bring it up here in case we need. Oh, maybe I'll leave this up here in case you need. No, on Alex, you can open the table or the calculator. Everyone is on. I'm gonna finish. Did you have a question? No, because they don't have a stamp.
Yeah, I'll just.
Yeah, it's just like
right.
Okay, yeah. Okay, so they want us to shade below 9. So the first thing you want to do, find the Z value, and then you'll put it here. So I'll find the Z value. It's the X value that they give you. Minus the Z. And divide by the standard.
Yes. So why do we use 18?
I mean, that's way too hard. Yeah, what's happening is it's only taken 3 divided by 4 and then subtracting.
Yeah.
Yes, the one thing, like, I was just gonna take everything along, I know I'm doing it, you know what I mean? Like,
Mhm.
but it's just.
Yep, whenever you have a fraction, we put it in front. Or do it separately. You want the top part, 9 minus 3.
Oh, no, no.
Wait,
There we go. Because when you get an answer here, it should usually between 3 and -3, so 9 there. If it's much larger than that.
what is 6 and use the lowest? 15.
Just shoot.
Did it say below?
Dude,
Oh, yeah, it was shaded below, so yeah. Mhm.
6 credit points.
Jeff, is that all you have to do?
Yeah, I think
Right
so.
now? Okay.
Yeah, I'm just kind of.
Yes, it was just those parentheses.
Okay, thank you.
You do okay, I do.
Surprise, you should have seen that. I think everyone here turned their project in, right?
Yeah.
Don't forget to do 5 responses by Sunday. This doesn't have to be anything detailed, just, I want you to get to see some of them and compare them with what you did, and so just write something nice, don't be negative. How did you find it?
Again? You are so quiet.
Reason you're getting a negative.
Service being, I was here, so we try to figure out.
Yeah.
Just in the
Never.
number. Oh, it's that. Which one did you want?
This one is here. This one is all of this. And so you subtracted this one first. And so that's why it's giving you a negative answer.
Oh.
It's the correct answer. It's just two signs, it's just subtracted.
Okay, so it would just be 0.22 mil.
At least three decimal places. Two, that sign would be out, right? So it would be 2, 3. Or 2, 3.
So that's.
Okay, so this one is someone put it in class, yes. So we use this thing. The mean would still be the same as the mean.
Because I asked, because we're like, you know, I'm 67.
Oh, okay. So you want
Because you're tears.
or less. You're using this for the X value. This is 10. So when I find C. Today, that's the X value. So the X would be the 0.907 minus the mean. Divided by the mean.
Like, we have to do these.
This is just their sample size. Is that?
Yeah.
Did you read it? Sir? Yeah. He said.
I think. Oh, they want to find C. Oh, wow. Okay. So you got your curve, and we move this.
And we put them. Your advice.
if we find this value, then we can work backwards. Let's see. So you want to find this value first.
So like, because my aunt, she's from Tuesday.
Okay, so first, finding the probability here. So together, then, if we add these two, that would be the probability of being.
Because they're applying. Just help. Okay.
Now, okay, if you're gonna use the table, you look for this value in the middle of the table and then go outward. If you use the calculator, you have to find this first. Would you use the calculator? Would you? See, for the table, you just look for this number. So in the middle, we look for 0.978. So it's 2.0.
That's why So this one, these and these would be.
Probability should always be positive.
Okay, so it's always gonna be.
Always.
Okay.
Your Z value can be positive or negative, but the probabilities under the curve are always positive. Did you have a question
Maybe. Yeah. This one. It's just kind of the awesome instead. Because I think I, block was like in between, so I divided by 2. That's what I can say.
Is this what we wanted this side or we wanted this side? I think we wanted it
Right,
up.
yeah.
So when we looked it up using the table or the calculator, it gave us below. So then we had to subtract from 1 to get above.
Okay.
Because the 2 together will add to 1.
Right.
Yeah.
When what? Your project? It's already.
Oh, yeah, and like great.
Oh, Sunday night or the next. I graded some of them who had already done 5 responses, so there's already grade. But, yeah, this is the responses, wait till that's done.
But I actually.
If you get all your responses done, it'll probably be graded in a day.
I don't know, I should have been moving on.
Oh, okay, yeah. That would.
Yes, with your gut, and I told them Thursday.
On some of these, you wanna be careful, rather than the decimal, they want you to multiply by 100 and give the percent. So be careful of that. Using the calculator or the table, I would use the table or use both and check your answers because you're gonna have the table for the in-class part of the test. Is it this one?
Yep.
So they gave you this answer, right? And then you looked up -1.21. Did you look up the -1 or the positive? So then you want to look at this 597. So it'd be between these two, go to the closer one, so it's this one. 1.2, is that what you used? Oh, the reason it's coming up negative, the calculator does this value. So you want to take 1 minus. So if you use this value, it will give you the positive. So that's the one thing about the calculator, it goes above. Just on that part.
It's